Hi dear students and viewers, welcome back to our channel Vinay Kumar Basics of Physics. Dear students, in this video I am going to explain one particular important question, that is the draw and explain current voltage characteristics of PN junction diode. So to understand this one, children, you must have idea about the how the PN junction diode should be acts in the forward bias and how the PN junction diode should be acts in reverse bias. When you have idea about these two topics, then only this content will reach you very easily. Otherwise, it is a little bit difficult to understand. So if you have no idea about the how the PN junction diode can be accessed in forward bias and how the PN junction should be acts in the reverse bias. So for that already I uploaded two videos. For that you have to go to the playlist of semiconductors in my channel and go and search for these particular videos and watch it. After that only you come to here. Otherwise this topic was not clear to you. So now coming to the point, the PN junction diode. Here in this diagram we are showing that this is the P and this is the N. What is mean by forward bias connection? How the PN junction diode should be connected in forward bias? When P is given to positive and N is given to negative. That means P is given to higher potential of the battery and N is given to the lower potential of the battery. Then the diode is said to be in forward bias. So when it is given like that, here in this circuit some voltmeter is connected and this is a milliammeter. Voltmeter can be connected to measure the voltage and this should be measured to find out the current. So while doing the experiment by using this circuit, we are getting the graph between the, if you can draw the graph between the forward bias current and voltage, the graph should be shown like this. The graph should be shown like this. So here already I think you have some idea about the PN junction diode forward bias. In forward bias, what is there? So I need some space, children, that's why I am erasing this one. Here this is the p-type material and this is the n-type material. So P and this is the N. When the PN junction diode is ready to give a battery, on that condition, on that time, here there is some barrier is there. Clear? So here simply some negative it is there and this the positive will be there. Because of here some positive immobile charges are created at the junction in N side, and due to the like this, here minus. In P side, negative charges are created like this. The positive charge will be created in N-type material near the junction, and at the junction in P side material some negative charge will be developed. So due to that some potential will be created, here it is there. Clear? So after that what we are saying, when the P is given to positive, and N is given to some negative here like this. At the starting here, when it is given to battery, initially when we have plot the graph between these one, voltage and current, initially there is no current. Why? Because already this barrier potential has some value. That's why here in the graph here from 0 to 1 volt, there is no particular current. We are not showing any value along the y-axis. It means that what? The voltage supplied by the battery, that is useful to the overcome the potential barrier or barrier potential. That's why we are not getting any current in this case. Got it? When a PN junction diode it is ready to give a battery, in that PN junction diode at the junction some barrier is developed. that barrier has some potential. When we can give that particular potential, then only the holes and electrons are moved from one side to the another side, then the current will be possible. So from this graph, what you have to understand, from 0 to 1 volt there is no current. That means what it is, simply here the 1 volt, it is nothing but here barrier potential. After 1 volt only, if again further you can increase the voltage, what you can observe, the current value is increases. Current value is here increases. You can observe here from, this is I am saying O and it is A. From O to A, what you can observe, this is the 0 origin and this is the O and it is A. In the graph here, when voltage increases, here 0, 1, 2 up to here, 0, 1, 2 up to here, what you observe, when there is, even the voltage increase, there is some small increase in the current. From 0 to 1, it is, there is no current is there, almost all 0. When 1, 2 and up to here, before coming to 3, so 2.8, 2.9 like that, up to there is change in current is very little bit is there. When voltage increases, but the current is increased in the less amount. Clear? But at particular 1 voltage, I am saying now in this graph, at the 3 voltage, the current is rapidly increases. The current is rapidly increases. When the current is rapidly increases, for particular voltage, the current should be going to be increased rapidly. That particular voltage is called threshold voltage or cutoff voltage, and it is also called as knee voltage. Clear? So what you have to say? Simply, what is meant by threshold or current voltage, current cutoff? Threshold voltage or cutoff voltage or knee voltage. What it means? When the PN junction diode is in forward bias at particular 1 voltage or beyond one particular voltage, the current is rapidly increases. It means that if there is any small change in the voltage, the current is increased rapidly. Then that particular voltage, what you have to say? Threshold voltage or cutoff voltage. It is also called as knee voltage. Clear? So children, this is simply about the voltage current characteristics in forward bias of a PN junction diode. You have to remember in forward bias only 3 things. The first thing is what? Initially there is no current in the milliammeter. Why? Because up to 1 volt there is no current shown in the milliammeter. It means that what? There is no rise in the current because of the voltage what it is applied initially, that is useful to overcome the barrier potential. And after that further what you say, when the voltage increases but the increase in current is very less. So that is we are showing from here 1, 2 and before 3. And beyond the 3 from 3 what you have to say, even though there is small change in voltage, the current is rapidly increases. That's why here what you have to say, that particular voltage what we call threshold voltage or cutoff voltage, it is also called as knee voltage. Now we can go for reverse bias characteristics. In reverse bias of PN junction diode, how the characteristics are there? Let's see here. What is meant by reverse bias of PN junction diode? P is given to negative and N is given to positive. So what you observe in P-type semiconductor, in P-type semiconductor and N-type semiconductors, some holes are the majority and electrons are the minority. In P-type, holes are the majority. In N-type, electrons are the majority. In P-type, electrons are the minority, and in N-type, holes are the minority. You have to remember that. So what do you know? Simply here, this is the p-type PN junction diode. P is given to minus and N is given to positive. In that circuit, some voltmeter is connected to find out the voltage here, and there is some milliammeter is there that should be used to find out the current. While we are doing the experiment, if you can plot the graph between voltage and current, that should be shown like this. Clear? There is some characteristics of V, I, and this is V and this is the I. This should be shown is as shown in figure. So to understand that, simply you have to remember what it is. In PN junction diode, the barrier potential is there. Barrier potential is there. So here symbol, this is the p-type material and this is the n-type material and this is the barrier potential, and P is given to minus and N is given to positive. Clear? So what do you know? At the barrier here some positive will be created in N side and here minus will be created in P, at the junction in P side. Then what I have to say, here minus is there, here plus is there. So after formation of barrier potential, there is no moving of holes from P side to the N side and electrons from N side to the P side. Already we know that. So, but in this case also reverse bias current is there. So in our forward bias, what we know, holes and electrons are continuously crossing the junction, then obviously the barrier resistance is going to be decreased and the current is increased. It is well known thing for us in forward bias. Actually here when it is given like this, here holes are the majority, and here electrons are the minority. Sorry, electrons are the majority. Holes are the majority here and electrons are the majority here. When it is given in the forward bias, what you have to say, holes are attracted by the negative terminal of the battery and electrons are attracted by the positive terminal of the battery in reverse bias. It means that what, holes are not crossing the junction and electrons are not crossing the junction because they move in opposite directions. Then obviously the barrier resistance is going to be increased. So what we know, when holes and electrons are crosses the junction, then only some here current is possible. But in reverse bias characteristics, we are showing that there is some current. Here there is some current is there. It is clearly shown in the graph. Then how it is possible? What we know, when holes and electrons are crossing the junction, then only current is possible. But in this case, holes are moving opposite direction and these are also moving like this, because they are attracted by the opposite terms of the battery. Then how the current is possible in reverse bias? To understand that, one concept is there. In reverse bias, only the current is possible because of minority charge carriers. So here, look here. In reverse bias, here from O to, I am saying now it is some A, whatever maybe. This is the origin O or 0. Here O2 up to A, there is some small amount of current that should be stable. Even though voltage increases, there is no change in the current value. It is almost or seems to be like constant. After moving some distance, after particular some value of voltage, there is some sudden rise in the current. That is what we call reverse saturation current. Here my question is, while the holes and electrons are not crossing the junction, how the current is possible in reverse bias? That is how to learn. So in reverse bias, at a particular voltage, the reverse current is going to be increased suddenly. Then it is a maximum of current in the reverse bias. That is what we call reverse saturation current, and that particular voltage is called breakdown voltage. What it is called, children? Breakdown voltage. Clear? Now here two questions. The first question is, why from here to here the current is very less and it is constant. Even though voltage value increases, there is no rise, only minimum amount of current is there. But while we are increasing the reverse bias voltage at particular one voltage, the current is becomes to be maximum. What's the reason for that? To understand that, here simply again I am going to draw the PN junction diode diagram here very clearly. To understand that, you have to watch very clearly. Don't skip the video. Here now, this is the PN junction diode. PN junction diode. Here what it is, in N side the junction what is there? Positive charge is there. Positive charge is there. In P type what is there? Negative charge is there. That means here minus charge is there. So after that, here in N type holes are the majority. In N type holes are the minor charges. Minority charges. Here electrons are the minority and holes are the majority. In this case, you have to understand these minor charges, holes are attracted by this negative charge. That's why these holes are moving from N side to the P side. Similarly, in P type, electrons are the minority charge carriers. They can be attracted by the positive charge. That's why what you have to say here, minority charges are moving from one place to the another place, or one side to the another side across the junction. Across the junction. That's why here reverse current is possible, and that is very little bit, because the minority charges are only moving across the junction. Majority are not moving. Clear? In reverse bias, there is no current off because of major charge carriers or majority charge carriers. In PN junction diode reverse bias, there is no current because of, that's what you have to say, majority charge carriers. But the current is only because of minority charge carriers. In case of majority charge carriers, there is no current, but minority charge carriers can moving across the junction. That's why some current is possible. And after further increasing the voltage, what you have to say here, there is some rise in the sudden rise in the current, and that particular current is what we call reverse saturation current, and that voltage is called breakdown voltage. Here the second question is what? Why there is some sudden rise in the current? For that, what's the reason? How the breakdown voltage should be takes place? Look here again. The breakdown voltage is because of here two things. One is here called, children, avalanche breakdown, and second one is the Zener breakdown. So to understand that, here simply this is the P type and this is the N type. Clear? First we can go for avalanche breakdown. How it is takes place? When reverse bias voltage increases, then obviously the minority charge carriers which are moving from N side to the P side and P side to the N side. The electrons are moving from P side to the N side and holes are moving from N side to the P side. These are only minority charge carriers. While they are moving from one side to another side, they will collide with the combined whole pair of the, again what you have to say, during the diffusion of current, holes and electrons are combined together. That's why while the minority charge carriers moving across the junction, they will create the more number of charge carriers with collisions. When they are collided with the pair of the electron hole, they can be separated. So that's why here there is some sudden rise in the current at particular one voltage. Then that breakdown is what we call avalanche breakdown voltage. What is avalanche breakdown voltage? How the avalanche breakdown voltage takes place? Very simple. Due to the moving of the minority charge carriers from one side to the other side, they will collide with the other pair of the electron holes, Due to that, some charge carriers will be increase. When the voltage is increase, the collisions also increase. Due to that, charges also increase. That's why in reverse bias also current is possible. And next thing is here, in case of GNR breakdown, when electric field is increase, when the reverse bias electric field is increase, then obviously the electron hole pairs will be breakdown. They will come out from their bond, covalent bonds. That's why the charges are going to be increase. Then obviously the current will be increase suddenly. This is the reason why we are getting the reverse bias current in PN junction diode. Clear? This is simply about the PN junction diode, forward bias and reverse bias characteristics. So dear students, if you can draw the both of them in the same graph, the graph should be like this. Up to now I explained separately. Here if you can plot the graph between voltage and current, the graph should be like this here. So this is used for forward bias. Then it should be like this. This is the forward bias voltage and this is the forward bias current. And if you can go for the reverse bias, as this should be like this. So this is the forward bias and this is now reverse bias characteristics. This is the voltage and this is the current. This is the voltage and this is the current. So if you can draw the both characteristics in the same graph, that should be seems like this. Okay dear students, if you can understand this one, like, share, comment the video and subscribe my channel to get the all notifications. Okay, thank you for watching.